In this video, we're going to take a look at how we can solve inequalities. In the last one, we looked at inequalities that were already solved out, and we could tell what our solution set was supposed to be. But now, as you can see by our first few examples, we have inequalities where we have our variable, but it's got company on its side of the inequality symbol. When we go to solve inequalities, this is going to be all about inverse operations, just like when we solved equations. In my first example here, I have x, and I want to get this by itself. I see that to x I'm adding 6, so I'm going to do the opposite of this, which is subtracting 6. When I subtract 6 from the left side, I get 0, so those are gone, and I'm just left with x. On the right-hand side, I have 4 minus 6, which is negative 2, and I'm going to bring down my inequality symbol and leave it in the middle. This is the same thing as solving the equation x plus 6 equals 4. We would subtract 6 from both sides and get x equals negative 2, except now instead of the equal sign, we have this inequality sign. And the graphing part is exactly the same as what we did in the last lesson. We put 0 on the graph, the answer that we got, and its opposite, and then we think about what we need. This is saying that x is less than or equal to negative 2. Because we have the or equal to, we're going to have a filled in circle, and we're saying that we want everything smaller or less than negative 2. Those values are to the left. If we think about possible solutions, 7 is going to be over here, way too big. 0 is not included in the graph, neither is 10, and neither is 9. However, negative 8 and negative 4 are going to be over here to the left, and those are solutions. Go ahead and pause the video and see if you can solve this inequality. Alright, in this example, we have our variable, and we're adding 5 to it. We undo addition of 5 by subtraction, and we end up with 2 is less than or equal to x. But remember, we want to flip that around so that the variable is on the left side. When we flip it around, we want to make sure that the inequality stays opening to whatever it was left at. So we have x is greater than or equal to 2. Because we have the or equal to, we're going to have a filled in circle here. And because we want values that are greater than 2, that arrow is going to go to the right. 3 and 9 are both larger than 2. Negative 5, negative 7, and 1 are not. Because we have the filled in circle and the or equal to, we can circle 2 as a possible solution. Now, when we solve inequalities, there's one new rule that we must remember. Anytime we multiply or divide on both sides by a negative number, we have to flip the sign. Think about if we have this inequality statement, 2 is less than 8. We know that this is true. But if I divide both sides by negative 2, now I have negative 1 is less than negative 4. And if I think about where those are on a number line, we know that that can't be right. Negative 1 can't be smaller than negative 4. So in order to fix this, we reverse the inequality and it becomes true. So anytime we multiply or divide on both sides as part of our solution, we need to flip the inequality symbol around. So if we look at our first example, this is negative 3 times x, which is greater than or equal to 12. In order to undo multiplication, we have to do division. So I'm going to divide on both sides by negative 3. As soon as I do that, I know that I'm going to have to flip the sign. So I'm immediately going to flip my inequality symbol around. Now, negative 3 divided by negative 3 is 1. That gives us x. And 12 divided by negative 3 is negative 4. So I'm going to go ahead, get all that on my graph, and I'll be good to go. Because we have the or equal to here, this is going to be a filled in circle, and we want everything less than negative 4. So we're going to go to the left. Negative 4 is included, but negative 1, 0, 8, 9, and negative 2 are not. For our next example, I see division by negative 5. We undo division with multiplication. But again, I need to multiply both sides by negative 5. In doing that, I'm going to have to flip my inequality symbol around. Negative 5 times x over negative 5 cancels out the division, and we're just left with x. And on the right-hand side, we have negative 10. So again, we can get everything on our graph. We're going to have just an open circle this time because we don't have any or equal to. And this is everything greater than negative 10. The larger numbers are to the right, so we draw our arrow off to the right. Negative 9 is one of our solutions, along with 0, negative 5, and 9. However, negative 10 is not included because we have the strictly greater than and the open circle. Negative 11 is to the left and is not part of our graph. Now, when we talk about multiplying or dividing by a negative, that means if we're doing it on both sides. If we look at this first example here, I do have a negative 24, but in order to isolate the variable, I'm going to divide both sides by positive 6. If I divide by positive 6, I do not need to flip my inequality symbol around, and we're just going to be left here with x is less than or equal to negative 4. So we can go ahead, set up our graph. I do have the or equal to here, so that means that negative 4 is included in my solution set, so I need the filled in circle. Because x is less than or equal to, that means that my graph is going to highlight the numbers to the left. Negative 4 is filled in and included, so we can circle it, but negative 1, 0, 8, 9, and negative 2 are not part of my solution set. The next example is the same idea. Even though I have a negative 5 here, in order to isolate my variable, I'm multiplying by positive 4. Multiplying by positive 4 does not mean that I need to flip the inequality sign, so I solve normally and keep everything as it is. We end up with x is greater than negative 20, which means that negative 20 cannot be included because it's strictly greater than. So we're going to have an open circle at negative 20, and the values greater than that or more than that are going to be to the right. Negative 9, negative 5, negative 10, negative 11, 9, and 0 are all part of my solution set because all of those numbers are greater than negative 20. So now we want to take a look and make sure that we know when we're supposed to flip the inequality sign. We'll do a few examples and then we'll leave you to do the rest on your own. Here I have negative 7 times x is greater than 21. In order to undo multiplication by negative 7, I need to divide on both sides by negative 7. When I do that, I'm going to have to flip the sign, so I'm going to circle this problem. In my next example, in order to isolate x, I'm going to multiply on both sides by positive 5. I'm not multiplying by a negative number, so I do not need to flip the sign. In the next example, however, I have division by negative 6. In order to undo that, I need to multiply by negative 6. Because I'm multiplying on both sides by a negative, I need to circle this problem and I need to flip the inequality. For this last example, even though things are turned around, I see division by negative 7. In order to undo that, I need to multiply on both sides by negative 7. Because I'm multiplying on both sides by a number, that means that my inequality is going to have to flip, and we're going to circle this problem. Go ahead and pause the video and see if you can identify the other problems where you would need to flip the inequality symbol. Go ahead and check your work. In the second row here, the only ones where we would need to flip are this problem, where we need to multiply by negative 9, and this problem, where we need to divide by negative 2. In the last row, here we would need to multiply by negative 10, and in this one, remember that when there's no coefficient there, there's a 1. So this would be negative 1, we would need to divide both sides by negative 1, and we would need to flip the sign. Everything else, we're just dividing or multiplying by positive numbers, which means that we do not need to flip the inequality. When we solve two-step inequalities, this is exactly the same as solving a two-step equation. But again, the only thing that we need to keep in mind is if we multiply or divide on both sides by a negative, we're going to have to flip that inequality symbol around. So again, the first thing I'm going to do is circle my variable group. Outside that circle, I see a positive 3. The opposite of that is going to be a negative 3. So we're going to subtract 3 from both sides. That goes to 0, and all that's left is positive 4x. I subtracted, did not multiply or divide by a negative, so my inequality symbol stays the same. 11 minus 3 is 8. Now I see multiplication, 4 times x. We undo that with division by 4 on both sides. I'm dividing by positive 4, so my inequality symbol stays the same. We end up with x is less than 2. If I want to go to graph that, I get 0, 2, and its opposite. This is strictly less than, so this is an open circle at 2, and the smaller values are to the left, so we draw this way. Now when I think about possible solutions, 2 cannot be a possible solution because it's not included. However, 1 is less than 2, as well as 0, negative 8, and negative 4. 8 is not, so we cannot circle it as a solution. Go ahead and pause the video and try the next example on your own. In this one, we have a positive 6 outside of our variable group, so we subtract 6 to undo that. Then we are left with 12 is less than or equal to 2x. We did not flip the sign here because we did not multiply or divide by a negative. 2x is the same as 2 times x, and we're going to undo that with division by positive 2. If we're dividing by a positive, we do not need to flip the sign, so it stays the same. However, once we're finished, we end up with the variable on the right side, and we don't always like to see that. So we're going to reverse the order, flip the x and the 6, but then we also need to make sure that the inequality symbol is still open to the x. Because it's greater than or equal to, we have the filled in circle, which means that x is included as a solution. Because it's greater than, we have everything going off to the right, and the only other number that we can circle is 7. If we look at our next example here, this whole problem is a fraction, so that means the first thing that I need to do is undo that division by multiplying both sides by 3. Because I'm multiplying by a positive 3, I do not need to flip the inequality sign. So we have 12 is less than x plus 5. Again, this is the same thing as an equation, just keeping in mind about the inequality symbol. Now we're going to undo that addition by 5 with subtraction, and we end up with 7 is less than x. But again, we want to put the x on the left-hand side and the number on the right, and the inequality symbol should be opening up to the x. We're going to go ahead and get our graph set up. And now this is strictly greater than, so it's going to be an open circle at 7. And greater than means we want all the numbers that are bigger than 7. So our arrow is going to go to the right where those bigger numbers live. 2, 0, -7, and -8 are all smaller than 7, so they cannot be part of our solution set. 7 is not included here because we have the open circle, so we cannot circle it. 10 is the only value that is greater than 7. Go ahead and pause the video and try this last example on your own. Alright, check your answer. Did you catch the part where you had to flip the sign? The first thing that we had to do here was subtract 4 from both sides. Because it's not multiplication or division by a negative, we leave the inequality as it was. However, in the next step, we have division by -3. The only way to undo that is to multiply both sides by -3. Because we multiply both sides by a negative value, we must flip the inequality symbol around in order to maintain balance. That leaves us with our answer of x is less than or equal to -6. Because we have the or equal to, we have a filled in circle, and because it's less than, we draw the arrow to the left where the smaller numbers are. We can circle -6 because it is included here, and -7 is smaller than -6. -4 should not be circled and is not a solution.